This is the solution to the Fall 2017 exam, problem number 13. We have a projectile that is hitting a rod that's rotating with an angular velocity of 4 radians per second. The rod is 2 meters long. And for this problem, we're asked what is the lowest speed that projectile needs to have to completely stop the rod. Now you'll notice that it is not stipulated where the projectile has to hit the rod, but we can infer that from the condition that we're asked for the smallest velocity that the projectile can have. If the projectile hits dead on perpendicular to the rod at the furthest speed from the furthest distance from the pivot possible, a full meter, then that is where the velocity can be the smallest. If it were to strike the rod anywhere closer to the pivot, it would need a larger velocity to stop the rotation. And similarly, if the direction of the bullet was not perpendicular to the rod, if it was coming out at an angle, it would have to also be bigger to make up for the fact that it's the cross product of the velocity and the radial distance. Another way of saying that is mv/r perp. So because we are told that it has to be the smallest velocity, we know that the projectile is striking at the r perpendicular furthest from the pivot. And now solving this problem is a matter of conservation of angular momentum. So we have that initial angular momentum equals final angular momentum. One of the things that makes this problem easy is we're told that the projectile is stopping the rod from rotating, so the final angular momentum is 0. That means that the initial angular momentum has to be 0 as well. And so we know the angular momentum of the bullet plus the angular momentum of the rod has to add up to 0. Now we write out an expression for that. The angular momentum of the bullet is its mass times its velocity times the perpendicular distance, this distance from the pivot, which is going to be 1 meter. And then we have to add on to that the angular momentum of the rotating rod, which is going to be the moment of inertia of the rod times omega. And now we plug in numbers, and we know the mass of the bullet. We know that it's going to strike 1 meter from the pivot, and the velocity is unknown. We know that the moment of inertia is 1/12 ml squared, which is 1/12 1 times 2 squared. And we know that omega is 4 radians per second, and that 4 radians per second is going in the opposite direction of the bullet, hence the minus sign. And now when we just do the calculation, we end up getting that 0.003 V equals 4/3. And when we calculate what V equals, we get 444 meters per second, and that is the solution to the problem.